Hey everyone, this is Stacy with SF Johnson Consulting and Construction Services. And in this video, we are going to do a deep dive into the S plans, S as in Stacy, S as in structural set. And I'm going to, in this, probably give you more information than you actually need, but that is a good thing. Okay. So we're going to start with what what is the structural set all about? What are the component parts? What sheets are we looking at? How do we look at the plan view, section view, detail view for the component parts of what the structural set is all about? What is the structural set all about? Well, it holds up the structure, and the component parts are designed by structural engineers to make sure that the building can hold particular loads or weights. And that's the part we're going to kind of explain first because that is part of your quiz. And I want you to understand the technical portion of what you're looking at, not only how to analyze it for the takeoff and all that stuff. So if this is something you're interested in, make sure you join, like, subscribe, take a class, send me an email if there's something in particular you'd like to learn about. I can put 5, 10, 15, 3 hours worth of content up here for you. Feel free to email me at education@sfjohnsonconsulting.com. So let me make sure to transition the screen. All right. So we are looking at the cover sheet for the structural set. And if you look at any cover sheet, you're going to find load information. And when they say load, it's basically weight and how much the building can hold, including the building itself. Okay, and so when you're an estimator, it's not really something you care about, but it's good that you understand. Okay, and part of the quiz really is one of the questions on the quiz is to help you understand that. So let's talk about the different types of loads. Okay, there are three different types, and the structural set is designed to address all three, depending on the purpose of the building, what the building is going to be used for, and it has to be designed to carry the weight of whatever's inside the building and hold up the building itself. Okay, so we have three types of loads. We have dead loads, live loads, and environmental loads. Okay, and so the dead loads are basically just dead weight, right? Permanent weight. Okay, and that consists of the roof framing, the walls, the concrete slab, everything within the building is part of the dead load. Okay, the live load, that's temporary or movable stuff like people and equipment and snow and furniture. And then we have environmental loads, okay, which are wind, uh, hurricanes, wind, earthquakes, seismic activity, and soil also it takes into effect. So depending on the type of soil you have, it really depends on the type of foundation you're going to have to hold that dead load and all the live loads that come through, plus all of the environmental loads that could happen every winter. Okay, so think of the structural set are all the component parts that are help the building survive all of those loads. And each of the component parts are designed by the structural engineer based on the purpose of the building and what's going to be inside and the condition of where the building is, right? If it's in California, we definitely have a lot of seismic additions to anything uh, with respect to this, right? Because of the earthquake in places where they have hurricanes or places where the water might rise. The foundations are going to be not slab on grade, right? There'll probably be piles where piles are different than slab on grade, which is different than any of the other forms, and so we'll talk a little bit about that. Okay. And so three types of loads: dead, live, and environmental. Okay. And so let's talk about the path because we have two paths. Okay, we have the vertical path, which is up and down, and then we have in terms of the load. Okay, so the load, we have a vertical up and down path, but we also have a load path that's lateral, that hits up against the sides. And so, again, the component parts in the structural set are designed to take care of those things. So, the vertical path. Okay, so think about the vertical from top to bottom. I mean, think about, and now you get a chance to think about what's part of the structural set, because the vertical path is basically all the component parts in a structural set that keeps the building up. Okay, so first we have the top of the building. Okay, and the roof framing. Okay, that's where the load starts. Okay, it starts at the roof, right? The roof deck, the trusses. Okay, that's where the load starts. And those things are carried by what? They're carried by beams. Okay, so think of going from the top of a building down to its foundation. That's the load path, the vertical load path we're talking about. So the top of it is the roof. It weighs a certain amount. That's why we have to have headers for windows and doors. Because if we take out a structural wall, which is any exterior portion, any exterior wall, we have to size that back up because we have to be able to hold that load of that roof, because the thing that was holding it up was a solid wall on concrete. Well, now we have put a window, which is basically compromising that strength by putting that hole there. So we have to strengthen it back up. And that's what window and door footers, I'm sorry, not footers, headers are for. Okay, so headers, although you may see them in the architectural set, they're really a part of the structural set. So you get what? Three 2x4s plus something to fit the opening. Okay, those are structural components. Okay, so vertical load path. The roof then sits on what? On the roof deck, the trusses. That's carried by the beams. And then we go down to the beams and the girders. Okay, so the beams and the girders again collect the roof and the floor loads. Okay, and they distribute them to the columns or the load bearing walls, which are typically the walls of the perimeter of the building and some that come in the building. Okay, and then we have the columns and the bearing walls. And laterally, we're keeping going down, right? And that weight is distributed into what? The concrete foundation. And then, of course, the concrete foundation, that whole load is distributed into the earth. And so the vertical path again is the roof to the beams, to the columns and structural walls, down to the concrete foundation and into the earth. Okay. And so that's the vertical path. For the lateral loads, okay, we have the shear walls, right? We frame an existing wall in certain positions with extra plywood and tighten it up with a lot of nails and additional framing over the existing framing. Those are the shear walls and braced walls. Those take care of the lateral loads, and that's our lateral load path. So shear walls, diaphragms, and anchorage and hold downs. Okay, and we all know what those are if you look at a set of plans. Okay, so how the structural set document the load path? Well, yeah, we have the framing plans, we have the roof framing plans, then they show us sections that we have to be able to interpret. And then sections, we also interpret schedules, so that schedules will tell us the size of the continuous footer, the spacing, the reinforcement, all of that. And then notes and specifications, of course, are the details that give us information about the load values. Okay, but we really don't need that. Okay, so just wanted to give you an idea of what are we looking at when we look at the structural set. Okay, so now let's look at the, this is the cover sheet. Of course, the cover sheet is going to give you all the information about what is here. And this is not so good of a cover sheet because I don't see the sheets that are comprised within the set, but they're here. All right, so the foundation. So in this, and when you look at a set of plans, they're usually starting from the bottom up. So the first set you'll see would be, and it really depends. I shouldn't generalize, but in most cases you'll see the foundation. Okay, and so what do we see? It's the bottom, and the foundation comprises of two or three components. It really depends on what the building use is. Right, we have the slab. Okay, so it's going to tell us the thickness of the slab on grade, and that W/WWF is not a wrestling team. It is a configuration of mesh rebar that we put in the slab for reinforcement. Okay, so we have to know what that is. Okay, and then we have the foundation. So foundation footing, or the perimeter of the foundation. So a foundation is pretty much three components: the slab on grade, the continuous footer, which basically is the perimeter and all of the section views outline where we have to go to get details about all the configuration of what here is representing a foundation footing. Okay, so how do we know the component parts in a structural set? Okay, so everything, I mean, you look at this, it tells you thick set tile, finished floor, but it's on top of a 4-inch concrete slab on grade. Okay, so we know in the structural set is the set with the least amount of plans, with the least amount of sheets, I should say. Okay, so we have the foundation, we have the framing, we may have the shear walls if it applies to that. Um, and then the roof framing shows us also the headers. And so we don't have very many sheets in a structural set. And then everything that comes after that are all of the details and the section views. Okay, so when we look at the foundation plan again, a foundation is three component parts: the slab on grade, the continuous footer, and then, yeah, in some cases, we're going to have column pads, which is represented by here. So, how do they tell us how they represent the column pad? It's just a square. Imagine in a parking lot, right? There's always some square piece of concrete, maybe that something is sitting on, maybe the light pole or whatever. It's the same thing here, where the column, which is represented by this symbol, this square, and so that tells me that we have a column inside in what they call footing 6.0, and the footers, the column pads, I should say, are always square, so they don't have to give us what the other dimension is, right? It's 2 foot by 6 inch square, so both sides are 2, 6. Okay, so I mean it's really simple. Okay, so this is the plan view. This is the view from above, most basic of the views. And what can we do from the plan view? The only thing we can do really from the plan view is measure how the area of the uh, the concrete pad, and we can also measure the continuous footer. Okay, but it looks like, and I don't believe that this is from the ground up. So because there's a lot missing, this makes no sense if it's from, yeah, see, existing slab. So it's just a portion of it getting replaced. And so what we have to do now, if we were going to do the takeoff, we need to know this is a continuous footer of some kind that's going to be represented when we look at image A3 on picture S302. This is a section view marker where it's his little head, his hat, his leg, and his foot. That lets me know that whatever I'm referencing, looking from this direction, it's only this portion of the wall. And see, section view markers are very tricky because you see we have so many just lined up, and you have to make sure you understand the difference, where it breaks it off and continues. And it's really not that serious. As long as you represent the section that you see, you can go over by 5 feet. You'll be all right. Okay, so what this tells me is that A1 over 302, that is the section of the continuous footer from here to there. Okay, but we have that in quite a few places, right? So it's from here to there. And where we stop it where we see the other one, the other section view marker. It's so confusing sometimes for the first time, but it's not to where, oh, I'm going to, lose my mind kind of stuff. But you just have to know where to start. And this is kind of lame. Okay. But let's look at what it's trying to show us. Okay. Every time I mention a section view marker, whether it's a wall or a continuous footer, you want to think about it this way. You want to think about the view that you're going to see at A1 over A302. What am I going to see? Well, I'm going to see the interior construction at this portion of the continuous footer. Okay, so you want to imagine that this is his leg is a knife, and you're going to, like, this is a little piece of French bread or whatever, and you're going to cut it and open it up, and you're going to jump right in the middle, and you're going to look in the direction that his little hat's pointing. And what you're going to see is just the interior construction. So why do you need to see that? Well, if I'm the concrete person, I know that that continuous footer has a depth and a width and a height, and a height and all of that. And I have to be able to determine what that is in order to do a proper takeoff, in order to determine how many uh, cubic yards of concrete I need, how many linear feet of any particular size of rebar. Okay. And that's what we have to do. All right. So let's go look at any one. Let's go look at image A1 over S302. We got to find S302 somewhere over here. A1, 302, 301. Okay. Image A1. It's always starts instead of up here and then go to, like, so stupid how they do. Okay, so what do we see? We cut it like a knife, and now we're looking in the direction. So this helps you tremendously, right? If you're the concrete person. Now I know that the continuous footer is 2 by 1, and I know that it has a stem wall pretty much. We can call it a stem wall, and we can determine, because it is to scale, the height of the stem wall and the rebar configuration. I have L I got to put in. So what's this mean, right? This, it could pretend it's a piece of rebar, right? We cut it like a piece of French bread. Now we're standing in there and we see how the bread is made. It's pretty good, huh? The bottom, we have, let's start from the very bottom. So we have two number 10, number 10. I've been doing this all day and talking. Okay. Two number fives continuously. What's that mean? So the whole length of that section that I measured, okay, in this case, probably going to be the whole perimeter. This one section is probably the general footer, typical, right? Typical exterior wall section. Okay. So it's going to be 2 times whatever our length is of the perimeter wall. 2 times that is our number 5 rebar. Bam, we got that. Take off, done. For this one, we have to make it an L, but we have to determine the height of the L, right? How long is this piece? And I mean, well, it's to scale, so you really don't have to guess. Okay, so you can measure. So I need, and we're going to put it at every, what? Every 3 feet on center max, right? So we need to produce these L's, right? And we have to put one every 3 feet. So if we had 300 feet, right? 300 divided by 3, then we'd have to make 100 of those and put it every 3 feet. That's how that works. So 100 times whatever the length is, then okay, I have an additional number 4 eh, that I have to produce. Okay, and then you work your way, you just go all the way up. And then we have two number fives horizontal, okay, along the perimeter. So basically, in terms of rebar count, it doesn't make a difference, it's the same. So you have four number fives on that perimeter, and then however many of those you have. And now cubic yards, you turn everything into cubic feet first and divide by 27. That gives you how many cubic yards of concrete. And again, your concrete has needs three dimensions, right? In order to get cubic. Cubic is three. So we have one dimension is that, the width, and then the height is the second, and then the third dimension is the length, right? Whatever we determine, we measured the length. So you multiply all those together, that's cubic feet, divide by 27, you got cubic yards. Same thing with this. Okay, what's the width of this wall, the height of the wall, and however long it is. And then we have these. How many? We got to do those. If we're the structural portion, those have to be in, or maybe not. It all depends. But we see that they're not marked here, and so they're not giving us detail about it. So it's somewhere else in the plans. We won't worry about it. Okay, but we just want to focus on, and all of the section views will give us the same thing. Okay, so existing is already gray, so what do we not have to worry about is this at all. We just have to do whatever the new stuff is. Okay, so yeah, we have to do all the new stuff. This, the insulation, and whatever else. So the section views are critical because you have to, and it's good when they have them to scale, so you don't have to guess if you, and then it's easy to eyeball it because they'll tell you, oh, this is, 2 feet. And I'll figure, okay, if that's 2 feet, then that's another 2 feet. That's 2 feet. Maybe that's 8 feet. I don't know. But it would be somewhere to tell you. All of the footers, there's a schedule for each of the footers, so you know the dimensions of them. And they're always square. So if it's a 3 foot footer, column base, it's 3 by 3. All right. So that's the foundation. That's the first part that we'll see. And it's always little other stuff. You know, we got to do other stuff. And all of the control joints, you got to look at the details on exactly how they want the thickness of it, what they want in it, all that good stuff. You got to be able to look at that. And so when you measure the length of the control joint, whatever you see there, it's that same in terms of material, in terms of the takeoff, it's the same length. And so same thing with the footer, okay? Um, Now let's look at this one, because what it's giving us is a section view through the column pad. So it's going to give us information not about the continuous footer part, this part, but it's going to give us information about the column pad. And what they could have done if all the column pads are the same, which they probably aren't, or if they are, they wasted a lot of ink. They could have just said, did one and said TYP. So every time I saw that symbol, I know it's the same makeup as the one they put TYP next to. So if you ever see that, that's what that means. And then here, here they're giving you how you have to reinforce the new to the existing. So that's really important. And the revision cloud, meaning they made some changes. And I see a lot of revision clouds without that. You have to have that because that's pointing to you to what to read on what was changed. Okay. All right. So let's look at one of these to see the difference between the section view at the continuous footer and the section. Isn't this fun? And the and the section view at the column pad. B1 over. It's getting late, and I'll be 61 in December, so I'm blaming everything on age these days. All right. B1A over 302. All right, let's see. Keep always going too far. 302, 301, 302. All right. B1A. Where is it? Here we go. Okay. So yeah, that is our column, right there. That's our column pad, edge of continuous wall. Okay, the continuous footer beyond that. So yeah, the continuous footer cuts off somewhere inside, maybe this or yeah, adjacent, but we can see that from the plans. Okay, so what we have to do in this case, it's got a lot going on. Okay, so yeah, it has this column pad, and then we have to determine this total. And again, it's probably just up against just next to the column pad. You have to see how far this is, continuous wall as detailed on the plan. So we'd have to see that one. Because, yeah, there's a couple of costs related to this when we talk about the takeoff and breaking it down. The footer, and look what the footer has on it, a lot, right? So the footer has one, two, three, four, five, six. Okay. And again, it doesn't give us the information here. Oh, is it number five, number four, whatever, whatever, because it tells us this. Okay. See your footing schedule. Each, we saw what, F6, F3, F da da da. Well, it's all over there. It's over there. Okay. Let's find it. Let's see. It might be on the front part. You never know. And I don't have my glasses on, so I'm really tripping. Oh, there we go. There we go. So we only have 5, 6, and 6.5. Okay. So they're 5 by 5 by 1, 6 by 6 by 1 and 2 inches. Da, 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 da. And that's okay. So one has 5 number, whatever's, and 6, and then 8. Okay. That's easy. Like my grandson says, that's easy. That's easy. And if you have a good tool like we do, you will get the cost per column pad. Okay, it will include the concrete, the reinforcement, the excavation, and maybe finishing. I don't know, something else. And then okay, so that's how you do that. Okay, so the length of, you see, it's all based on the plans, that insulation, that wall, that da da da. You know what I see? I see this, maybe this, whatever. Let's see where that wall is. That's very hard to determine. Maybe right here. That's kind of tricky. I just have to guess. We'd have to go from, it looks like more from here to there. It's, and we'd have to determine which side was that wall and which side was that insulation. Oh, that's probably the wall side. And that's the insulation. Makes sense. The insulation would be on the inside, right? Okay. All right. So that's the first part of the structural set, the foundation. Second part is the roof framing. Stacy is going to take a break, but you won't know it. And I'll be right back. All right. So now let's look at the structural framing plan and how they represent the portions of the framing. And so we know that the structural framing always begins at the roof if there is any. Okay. And how they represent it, it really depends on the type of member. And we say member, which is a generic term pretty much for uh, the framing piece. So a member is a, a beam is a member, or a column is a member, or joist is a member. Okay, so when we talk about structure or framing, we always try to use the right lingo. Okay, we say member. So what we're looking at here is they're showing us that they already have a lot of existing. It's most of it is already existing. They're just modifying it. But just so you'll know, There's so many different types of structural framing members. There's beams, there's columns. They're made of wood, they're made of steel, iron, whatever. But we know that it is a formed metal, and this type is fabricated metals. And when you see the W beam, that's what those are, beams, right? And it could represent the beam or the column. Okay, in this case, it's going this way, right? It's up against this line. So you got to think structural framing. This is the framing plan, right? The plan is the view from above. It's the framing plan. So it's as if we're in an airplane, there's no roof or anything. So we just see the rough framing. Okay. And so what we know from the plan is that these portions are W beams. Okay. And really, the number on the beam signifies the width of one of the parts of the beam, and the second number represents linear how many pounds per linear foot. Remember, structural frame is all about loads and weights and stuff. And that second number after the times symbol, it signifies how many pounds per linear foot that beam can hold. So again, which ones to use and all that, that depends on the structural engineer. But when you are estimating fabricated metals in this case, anytime you see that, those are priced by the pound, not by the square foot or by the linear foot. And so you have to be able to convert that beam to a weight. And it's very easy to do, right? Uh, you basically, if in this case, it's 50 pounds per linear foot. So you just got to figure out how many linear feet you have, right? If you have 1,000 linear feet, then you multiply 1,000 times 50, and that's the weight. And it's typically in tons. And yes, fabricated metals are priced by the ton, not by the square foot, not by the linear foot. And so anytime you use beams like that, you have to do the math and determine how many pounds you have. All right. Same W18 by 35. What's that mean? That, that means that it holds 35 pounds per linear foot. So once I know how many linear feet I have, I can determine the weight easy. Okay. Section views still apply, you know. Now let's look at some of these, because these section views don't apply to the foundation. These section views, even though some of them may be the same, typically they're not, but even if they are the same, we're not looking from the perspective of the foundation. We're looking from the perspective of the framing, okay, and all that good stuff. Okay, so we know that this is column 6. Okay, we don't see that column pad because I'm sure column 6 is sitting in a column pad that we just saw on the foundation. But why don't we see it here? Because this is not the foundation plan. This is all about the framing and the headers and all that stuff. All right, if there are any headers, there it looks like we have some new rooftop units installed. They're heavy. Okay, and it does say typical here. So whatever we see there, we can just do one and multiply it by however many we have. It looks like we have 2. So see, and as you see, when it's typical, which we see here, framing C2 S401 typical. Okay, so I'm going to go there, do those measurements. And this helps me a lot too. Now, they say, oh, do I need to? And I say, if you're in construction period, you should know how to read every set of plans, because there may be a time where the HVAC person needs to know, or the HVAC estimator needs to know the size of the supply and the return grills. Both of those have supply grill symbols, but you can come here because everything's to scale. So I'm sure I can measure that if I needed to determine something for a kid, or, it doesn't show me the size of, my 90 or whatever that I need to go up into the supply grill or the return grill. Oh, I could go to the structural set and boom, I could make a measurement and be close enough, right? So that's why it's important to know how to read every set of plans. All right. So let's go to A1 over S404. Steel framing. A1 404. Da, da, da. All right. So there's a lot here. Okay. For the purpose of a takeoff, oh my God, that's a lot. Because what do you have to do in terms of a takeoff? You have to, well, this part, I think we got that in, you know, continuation symbol. Okay. We should have gotten that from the plan view, right? The plan view will give us all the horizontal measures, but we need section views and detail views for the vertical measures. And so, yeah, we got to see what each one of these are. Is it to scale? Because if it's to scale, yes, it is. So if it's to scale, all of those little breakoffs and stuff don't matter. I can pretty much see it's 2 by 2 by 18 gauge with see this right here. This is a takeoff nightmare, but you can do it. Okay, you just have to do everything individually, and because it's to scale, this doesn't make a difference. You can still measure accurately. Anything's to scale, they somehow it's good. If there's a scale, you can scale it and measure. Because yes, you would have to measure every piece and part of all of this. This would probably be somewhere else. Yeah, because it cuts off. So yeah, you got to know what's going on under here. So we'll see the typical CFS framing details to get that. We can get that somewhere else, but for the purpose of this section view for our steel framing, we need it for all of this and for this. Okay. And I'm sure we have to see something else because that's not enough detail for anything. So they're going to send us somewhere else for that. Okay, so that's crazy framing, structural framing. That's why, hey, structural framing is a whole different beast than architectural set framing. Okay, you oh, because of this right here. Okay, and you've probably got a lot of them just like that. Oh yeah, you got a lot. I say, oh, we got to do that. Okay, we got to do that. And in order to do that, you got to be accurate, okay? Very much so. I did a suspension bridge once. Oh my God. But you got to be accurate or don't do it. All right. So this this set wasn't really, I mean, we didn't have any shear walls because in this one because there is no, I mean, it was a renovation. So, it'd just be one little sheet telling us to put some plywood somewhere. Nothing big. Okay, so that's the pretty much the, I mean, the structure set, the foundation, the columns and beams and girders and all the roof, uh, all of the roof framing stuff. Okay, you gotta know your W beams, your I beams. These use W beams. Okay, and these are just, we don't even care what these are, but they gave us the type of these. Okay, we don't care about the joists because, or do we? It's not existing, or is it? That's it. See, I don't know. I mean, for the purpose of this review, see, yeah, they already know prior to fabrication. Verify, okay, because that stuff's not cheap. Oh, okay. Roof deck shall be. Okay, so the roof. This is all. This is existing. It looks like, and then they putting on a new roof deck are adequate to support new loads without additional. Okay, maybe not. I don't know what they're doing. Tell you the truth, but I don't care for the purpose of this. All right, roof framing structural set. Nothing like architectural set framing. Okay, and then I think they have a high roof framing, and so and all of these are high, some structural steel, 8 by 4 by 1/4. Okay, so the where they put it, so they're telling you basically, though, that is the outer portion. Okay, and then these are this 100 1000 S1 62 da 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 joist at the 16th, typical max typical. Okay, and what this represents a column, right? Because we're looking from the plan view from above. So this is the high roof. They got a little high roof up there. Okay, so yeah, we gotta, if we were really doing this, these are all different. See, they changed it. You see how it's a different size for this stretch, and we typically go from column to column. Okay, unless it shows us something different. So that representation of the type of structural steel, pretty much beam, okay, we would say in terms of length that it's going to be going from column to column. From here, that's a column to there. And then, we got to look here and see what the connection's all about. That's what this is all about. And that's what this is about, showing us the connection between the joist and the outer portion of the beam. Okay, it's crazy. And so yeah, you basically have to. I mean, it really depends on you how you price it, but you know how you price it for your estimate and how the what you get off of say a cost book would more likely be you would do a cost per square foot, but in real life, you got to know how many linear feet of all this stuff you have and what, yeah, how many linear feet of each one of those that you have. Okay, so see, it says da 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 continuous from end of cant strip to grid 7.5. I'm sure that's what that means. All right. Interesting for the structural set. Okay, and then more details. Okay, foundation, how our pipes got to sit in, and yeah, you got to be able to do all those determining the how many cubic yards. So just make sure you got three dimensions: the width, the height, and the length. And that's your 3 divided by 27, and you have cubic yards. All right, so that's going to end this presentation of the structural set. And if you have any questions, concerns, reach out at education at sfjohnsonconsulting.com. And if you are a student, yes, complete your essay portion for this set. And no, you won't, because I got to make sure, hold on, that we are clear with everything you need to know for this test. So we did, let me go back. This is going to make it even longer. So where are we? Let's see. Conclusion is 4346. Conclusion 4346. All right. So we know how, what is that on my pen? We know how the load transfers. We know the dead loads, right? We know the how the roof framing is associated, the beams, the girders, the columns, the footers. We know what the lateral load is, right? Dead load, live loads, and environmental loads. You know that, and how each of the plans, right? So you'll be able to tell me how each of the component parts of the plan are related to the each of the load paths. Okay, just based on what I already told you. So make sure you can. Okay. Now we did go over the typical foundation. It has those three parts. Okay, but no, there are different types of footings. Okay, and it's important you know that. In commercial, we're always dealing with slab on grade, so which would basically be a type of mat, slab on grade, and that is a type of mat footing. Okay, and then we have spread footings, which are like the ones we saw on the plan, where it's a perimeter kind of thing, right? But it spreads out and it doesn't cover the full, and usually for commercial, and this for residential more than any commercial building, where we don't have it a mat like a slab on grade where the building just sits on top. Well, we spread them out to a distance to where the perimeter of the building is sitting on it nicely. And then we have the footing, the continuous footing that goes around, right? But then the building sits on stem walls. So we have the foundation footing, and then we build like we saw in some of the section views, that wall we saw. Well, yeah. And then the building structural walls are built on the stem wall. Okay, so that's a spread footing. And then I did mention piles, right? Depending on the type of soil the building is in, like at the beach or where the soil is unstable, like in, beachfront property. That's all I can really think, where you got to get right down into the bedrock of the dirt. There's no slab on grades there. And we use piles for those. Okay, so those are the types of foundations that you could possibly have. Okay. And again, spread footings, that's typically residential. The mats, you can associate mats with slab on grade. Okay, and we have that always in commercial. All right, I had to take that off. Hopefully you didn't hear that. All right, and we did go over reinforcement, how it's represented, how you look at it, how you count it up, and how it is represented, right? So you take that section view of the rebar at that section view, but before you even went to the section view, you determine how many linear feet was there, right? And so now if I know if I have four number fives, well, it's four, and I knew I had 100 feet, well, that's 400. So, and the notes, we know that the notes and the specifications tell us all about the means and methods, and the details show us, excuse me, show us details. Okay. So let's talk about something in general where I did mention you need to know how to read all of the plans. You need to know how to go from one set to the other because you may have uh, discrepancies in the plans. Okay. And so, yes, anytime there's a discrepancy in you're the concrete contractor and you're noticing maybe a discrepancy in, or you're the framer, let's do it that way. You're noticing the discrepancy in where the HVAC is going, where the framing is going. Well, then, yeah, you can go to the actual roof plan itself, and those should match up. And if they don't match up, that's a point of contention. That's something you tell somebody. Okay. So, yeah, you have to be able to know how to. I was mentioning before, if I'm the HVAC person, I don't know if I'm estimating, but it does show me uh, what's directly connected to each of the units. Hey, I may be able to go to that structural set because those openings should be to scale, and I can pretty much measure that enough to be accurate. Okay. And so you want to make sure to avoid any conflicts at all that you're able to go from set to set. Okay. You have to make sure you're able to go from set to set. Now, let's talk about requests for information because uh, in the structural set, there are a lot of missing things and can cause a lot of problems. So let me just go over some of the common structural requests for information triggers. So if you're the any portion of the structural set and you're doing the scope of work, these are common things that would trigger that. So, request for information, remember, it's used to clarify unclear plans or even the specifications, or to clear up any conflicts. And in most cases, remember, you only have a particular amount of time to submit that and to get your answer back. And so it's important to make sure you're following all the directions, because if you do it too late, it's too bad. So, common structural request for information triggers: missing beam and column connection details. You can't guess on those things, okay? And so you really do have to know if there are any rebar that is, you know, shown and doesn't give you the exact number. You got to know, okay? You have to know the footing depth, those things, okay? And I mean, though, it's just important. So those are the things really you want to ask them about. You don't want to guess, okay? What else? And the thing about it is, and we'll go over when inspections take place, at what points in each of the particular, and, and it's always at the structural portion or the rough end portion. Okay, if you don't make sure you get this information ahead of time, or make sure you have it upon inspection, and something's not right, they know it immediately. And what does that mean? That means that no, it's not going to pass, and you may have to do everything again on your own dime. Okay, and so it's important. Okay, you don't really need to know load information, but I've seen in a lot of situations where the shear wall uh, nailing details aren't there, and they'll say similar framing with similar framing. Well, make sure you always get the detail. Similar to what? The exterior wall, the interior wall. Those are the things you want to you know, get get cleared up. Let me think. It's probably overkill, but I think that's it. When it comes to, and really this is for self performers that are trying to do their own estimate. Okay, section views begin at plan view. Detail view begins at section view. Section view begins at plan view. So when you see the plan view, okay, plan view is the first view, right? Plan view is going to always trigger section view. And then when you go to section view, it may trigger detail view. And none of those views you want to bypass. You want to make sure you understand everything you see at each of the views. Okay. Um, Now, if you had to take a framing takeoff, and I said, what is the typical way to do your let's start with the foundation takeoff to get everything you need. Now, this is the way that I do it, because I know that, I mean, the slab on grade is what it is. It's a big square. That is the easiest thing to do if you have an area tool. Boom. It's 4 inches. You know the area. That's the easiest thing to do. But when it comes to the foundation footing, some portions may not be, as we saw from the section views, they may not be exactly the same. And so when it comes to any of the foundation footings, whether it's inside the building or the perimeter of the building, just follow all of the section views. Follow from beginning to end. So I would follow wherever it made sense, because I don't think any of this is getting done. So I'm in here, and I'm going to follow all of the section views wherever they lead me. Okay. And so I'll start here. And I know that this is a column pad. Okay. It's a It's a column pad that differs from that column pad. See, and when you look at the plans, you have to have very much of a detailed eye to know when things are different because, yes, that's why they're leading you to different section views, right? That's a column pad that has pretty much all four sides, right? This is a column pad. And I know it's a column pad because I see that's the representation of a column. And that is a column pad at the edge of whatever this is. Okay, so that's when they just put in. And so I know why they're leading me to a different section view, right? That's B1 over S302, but this is B1A, right? Why? Because yeah, it's different. It's different in construction. That has four. That has four sides. I'm sorry, people. I got to keep sending you the voicemail. And that has only two. So yes, they're going to give you different, you know, different views to look at. And now look, here I'm going out B1A, da da da, B1A. Okay, those look the same. So once I do one of them, I'm just gonna multiply by two, save you some time. And so it's important just to remember this section view is going through this section of the continuous footer because the architect is saying there's something different about the construction here between the column pad and the next column pad, which is this stretch. There's something different about that construction than is at the column pad itself. So, and you see A1302, A1302, A1302. I could just, measure all one, just keep measuring. I don't have to break that up because it's the same. And it's basically uh, the framing in between all of the column pads. So I'm just going to go all the way down and then incorporate each of the column pads individually or anything else that's different. Okay, so it's a little tricky, but plan view takes us to section view, and section view will take us to some other detail view if necessary. It may not be necessary. Okay, so any questions? I think now you're ready to pass the quiz. Any questions? Reach out at education at sfjohnsonconsulting.com.